Decision making under risk. Decision making under risk begins on page 327. In decision making under risk, we identify the expected monetary value, the weighted average of the possible payoffs for each alternative, the expected opportunity loss, or the expected cost of not picking the best solution, the expected value with perfect information. So if we had perfect information before our decision, what would be the expected payoff, and the expected value of perfect information, or the upper bound on what we would be willing to pay for information. You may want to take a moment and copy these titles, and we'll begin. We have the similar scenario as before, 3 options to build a large plant, a small plant, and no plant. Under decision making with risk, we have levels of risk, assessment of risk. That is shown on the probability line. Under the high outcome, we anticipate that there's a 30% chance that we'll have high demand, a 50% chance that demand will be moderate, and a 20% chance that there is low demand. The probabilities must add up to 1. Once we have the probabilities, we can go ahead and calculate the expected monetary value of our outcome. We can do that using the sum product method. We're going to take the sum product of the outcomes for the large plant and our probability, which we will set at absolute here. And that will give us the expected monetary value. We take the high of 200,000, multiply it times 30%. The moderate of 100,000, multiply it times 50%. The low of minus 120,000, multiply it times 20%. Then we add each of those products together. That gives us the expected monetary value of $86,000. Because I used absolute references for the probabilities, I can copy that down and find the expected monetary value for the other 2 alternatives. Then I want the maximum. That's the best choice. So if the value to my left equals the maximum of all of the values to my left, then it's the best choice. Otherwise, we'll leave it a blank. Now we calculate the regret scenario. You may want to take a moment and copy these titles onto your worksheet. We use the regret scenario to calculate the expected opportunity loss, or the cost of not picking the best solution, the level of regret. We do that in the same way that we did it when we calculated regret under uncertainty. We take the maximum of the high outcomes, make the rows absolute, and we subtract from that the outcome for the alternative at the demand level we are on. So in this case, we're the build a large plant alternative with the high outcome. That's $200,000. That gives us 0 regret. Copy that down. 110,000 regret for building a small plant, 200,000 for no plant, and copy it across, and you can see that looks like the regret outcomes from the section on decision making under uncertainty. Now we'll calculate the expected opportunity loss, again using the sum product. Take the sum product of the outcomes under this alternative and the probabilities. Set those to be absolute. That way we can copy this. It gives us 24,000 for the large plant, 62,000 for the small plant, 110,000 for no plant. We want to minimize our regret, so we will look at the value to our left, and if it equals the minimum of the values to our left, set that to be absolute, then it's the best option. Otherwise, we'll leave it a blank. Once we've determined the expected opportunity loss, we now need to calculate the best outcome and use these figures to calculate the expected value with perfect information, the best expected monetary value, and the expected value of perfect information. The best outcome is the maximum of the possible outcomes at each level of demand for each alternative. So I copy that across, and I see the best outcome for each $200,000, $100,000, and 0. You may want to pause the video and take a moment, copy these headings, and we'll calculate the expected value with perfect information, the expected monetary value, and the expected value of perfect information. The expected value with perfect information is the sum product of our best outcomes. If we had perfect information, we would have the best outcome and the probabilities of each outcome. You can use either row of probabilities, they're the same. That gives us an expected value with perfect information of $110,000. The best expected monetary value, we've already calculated that. So again, we'll take the maximum of our expected monetary values. That will give us the best expected monetary value. The expected value of perfect information is the expected value with perfect information less the best expected monetary value.